It has a list jurisdiction where as needed, right? So
yeah, one there's no like ongoing plan.
Yeah. Yeah.
Because it's ad hoc.
Yeah. Yeah.
When you say, okay, I'm starting with this. Transition. Because, okay, yes, electric. Got it. Everything. It's actually one of so it's not so like in that can you imagine yeah. Yeah, sure. That's a great parking situation. So now it's like a number of sort of open it's funny. It's like they try to yeah. Go to bed. The one that you're not gonna like is that you wake up. Yes. It will be like, maybe it's not such a good idea. I might be okay with it just because it sounds so small. This is my ladder.
Okay.
Yeah.
Right. Let's try something. Yes.
Hello. You guys ready to get started? So thanks once again for coming to tonight's meetup. Just a few quick announcements. Hey guys, you're gonna get started. Thank you. So a few quick announcements. Big Data DLA, August 5th, completely free. You guys have heard about it and are well and good. If not, please sign up. Just go to the Big Data DLA website or just go to the meetup page. There's information about that. We have another meetup on the 23rd with Paxata. It's going to be out here, same time, so feel free to join that. And with that, I want to thank our hosts, Data Science. So a round of applause for Gabe and Data Science for hosting us. And with that, I want to hand over the mic to Tom from IBM, who's going to talk about today's topic, which is Spark. And yeah, exactly.
Hi, everyone. Thank you, Shiva. And thank you, datascience.com, for hosting this. So a little bit about me. My name is Thomas Liakos. I was an open source systems engineer for about 11 years. And about 8 years of that time frame, I basically had hybrid infrastructure under my charge across multiple businesses. Different types of institutions, so from cybersecurity to media, commercial type of businesses, so ad serving, social networking, things like that. So. Prior to IBM, I was working as a systems architect at a blockchain firm called GEM. It's in Venice Beach. I don't know if you guys heard of them. So it's kind of in your guys' neighborhood. Yeah, I worked there for about a short stint, about a year, working on some applied blockchain technologies inside of the medical space. Helped with a lot of the architecture in terms of building out the moat around the blockchain, to say the least. And before that, crowdsourcing. So I'm at IBM now. I love it a lot. We do a lot with open source, and we do a lot with cloud and SaaS services. So we do have data science experience and some other tools under that, and lots of data platform. That's kind of what we cover. So, or I cover. So I like Spark, Python,
Config management tools like Chef. I know that's really funny to see. You know, who likes config management tools? Weirdos like me. Yeah, there you go. You're a weirdo too. Yeah, I'm a big fan of Chef myself. So I do like Ansible playbooks for patch management and things like that. But yeah, Hadoop and wrangling cats. The cats are developers usually, and also myself. So yeah, let's talk about the introduction to this talk. A little bit about it. I have a demo here that I'm going to show you, all encompassing. We're using the data science experience to kind of leverage the technology that we're using here. And with that, let's talk about data science experience. So how many of you know about datascience.com's platform? Used it? Okay, cool. So IBM has a product as well called the Data Science Experience. It's basically a tool that's made to learn, create, and collaborate amongst businesses, community, and also people that are learning about data science or are data scientists. A lot of the technologies inside of this are open source and leverage open source technologies. So we use a lot of, you can write code with Python, you can write code with Scala, and you can use R. Kind of cool thing about it is it's using Jupyter Notebooks. So how many of you are familiar with Jupyter Notebooks? Okay, good. I hope so. And how many of you are familiar with Spark intimately? Okay, great. Cool. So everything running data science experience is actually driven by Spark. So what I mean by that is Docker container spins up, Spark is actually executing that action and the code to launch the container, prepare your environment, get you going to write on this Cloud IDE. And the other thing too, not only do we have Jupyter Notebooks under the hood, we also have RStudio. So kind of cool aspect of data science experience. I'm going to mention just these two parts of the technology. Those two items, you can work kind of hand in hand. Work on your data, train a model, massage the data, put it into R, and actually do visualization on it. And kind of a cool thing, because not only can you do that, but you can share that with your team. There's internal controls, so you can share it amongst an organization or publicly. You can hook it in with GitHub and continuous integration as well. So kind of a cool thing to have if you're doing things like updating models or training them, and next thing you know, hey, I want to deploy this, development and staging prod. Guess what? This can do that for you. That can just be the beginning point. It also has a scheduler built into it, which is kind of cool, and connections for object stores. So kind of a cool aspect to this. What I was saying before, it's all about community, the open source initiative that we have here at IBM, and the IBM value, added value. So as you can see, as I stated before, we are trying to connect with data scientists, have you, use collaborative tools, ask questions. We have articles and papers similar to datascience.com in that respect, and we have capabilities to fork and share projects, whether it's in GitHub or internally inside of the data science experience. In addition to that, open source tools that I had mentioned, they're there. And also the IBM added value. So as you can see, we have Spark as a service. It's kind of the main gist of why you guys are here. You guys are Spark users. Everything, like I said, you have Spark Executor. You can allocate resources to the project that you have on data science experience, and then use the logical cores that it gives you and memory to run the actual project or notebook that you're running for whatever it is you need. So one other thing, the entire experience is tailored to these 4 personas: the data engineer, the data scientist, the app developer, and the business analyst. How many of you are actually data engineers or developers, or both? Okay, how many of you are data scientists? How many of you are systems engineers or operations folks? I knew you were. You're like I feel like me and you are connected. So, I don't know. Anyways, and how many of you are business analysts? No one? Okay. Wow, that's okay. We got one. Woo! All right. That's actually rare. It's like just one. I think most of my talks I run into like 2 or 3 or 10. So cool. So as many of you know, the data engineer is doing a lot of the heavy lifting, doing all the prep to load that data into an environment. We have a tool called Data Connect. It gives you about 25 different types of connection endpoints or connectors to access your data from various sources, including S3 and our Swift object store. The data scientist is going to be able to, you leverage data science experience, be able to get you the tools you need and get you integrated with what you need. The business analyst obviously is going to be looking at Watson Analytics for predictive analytics. I would also say that the data scientist would too in some respects after their data is massaged and tested, but most of the time business analysts will be looking at a tool like that, and the app developer or the operations person would be looking actually at Bluemix for it as a platform as a service, and that would be something that's more self-managed, one-click push button types of deployments. Bluemix is pretty much your gateway to all of this. It's your starting point. So all things considered, this is kind of the life cycle of these collaborative efforts, and this is how you're going to pretty much get your data to where it needs to be and to make sense of it. So from here, the notebook itself, you can use IBM's analytics for Apache Spark to pretty much blend all these data types down below, or data sources, excuse me. As I stated before, it's using the Spark core. So Spark framework's driving everything. Any questions regarding this? Okay, great. So let's go ahead and get to the demo. I just want to kind of give you my spiel on what the product is, kind of high level, and we'll get into it and also talk about the demonstration. So we're going to be modeling energy usage in the New York City boroughs using block power. How many of you know what block power is? Okay, so long story short, really cool company that likes to do a lot of these things for integrating and finding clean energy or improving energy efficiencies in cities. A lot of their work is with in some respects pro bono, or using clients that are churches, hospitals, things of that nature, very large institutions, where they're collecting this data and pretty much analyzing it. So we're going to use the data science experience to do that, and RStudio to do just that as well in the cloud. So, or more or less through my browser. So yeah. So let's go ahead and go through that. And so this is this is always hard to do with the Mac, by the way. So this is the data science experience. As I stated before, we have tiles here, give you articles, data sets, notebooks. Our main thing is we're going to be actually running a project. Sorry. There you go. Almost there. Okay. So within this project, we have a notebook. We have files that have loaded, by the way. So these files, the data that we're looking at are all CSV format. As I stated before, you could connect to a data source. So if you wanted an object store, database, NoSQL solution, whatever it may be, you can actually go to the connection section up here and pretty much connect to whatever you have already associated. And there are security controls for this as well. So FYI, if, for your benefit, you wouldn't have to run a real heavy audit on this because we would have a secure gateway set up. You can easily connect to your in-house solution or, in your cloud by using a direct connect in many respects that's secure VPN.
You're talking about VPN?
Yes, yes. So that secure gateway is going to give you that capability to access it.
Quick question, are you using
No.
transfer, direct transfer?
No. Good question, though. Yeah, so as far as the connection, we go, you have your connection strings, just fill those out. you're off to the races to access your data source. So here are the objects in the object store. I'm using pretty much a default configuration, so I'm using just a single executor, which is only a few gigs of RAM and a single logical port. A lot harder than it looks, by the way, moving the mouse. So, just an FYI, the white paper that this was actually based off of is located here at this URL, which is a contribution from CUNY Institute and IBM's Watson research lab, as well as another university. Where is that? McMaster's. So these great people actually pulled together modeling and simulation of building energy performance for portfolios of public buildings. This white paper is what would actually derive this use case inside of the data science experience. So if you also want to access this this notebook, Greg Filla, close friend of mine, he was the originator of this notebook. It's actually on GitHub, so if you ever want to access it and play with it, please feel free. We've done some work on it, looking to update it to Spark 2.0, 2.x actually. We're using 1.6 right now, and Python 2.7. By the way, I'm not going to upgrade it to Python 3.x at all, so don't even ask. I'm a 2.x too, so yeah. So here's the block power data buildings in New York City. So here's the setup. I'm going to go ahead and run through this. This is a really bad angle, but if anyone has any questions about this, what we're doing is I'm going to just kind of present to you this notebook. I'm going to show you RStudio and how it kind of works overall. It seems like this group is a little more of you guys want to see more of the functional use, or more or less you want to see RStudio in the shiny app? Okay, but you guys want to see this first? Yeah. Okay, cool. Just want to double check. Steve is over here, likes to see the visualization first. He's all business. Yes. All right, so let's go ahead and run through it. So the setup here is actually asking us to load data. I've already loaded the data, as you saw earlier. Simply do just that. You would drop it from here or create a connection, or you'd already have it in your object store like so. And that could be done through a REST API, by the way. So similar to S3, you would be able to load this data into the object store and then just start working from it per a scheduled action or manually. You could actually even have this running the entire time and just wait for data to land and then execute repeatedly. So as stated here, we've loaded the data. We're gonna go ahead and take a look here. So as you can see, there's a SQL context here. I'm taking this data from the CSV file and just giving you a visualization of what this data looks like in terms of total square feet, plug-in outlets, number of stories, the year of the construction of the building, and the electrical usage. There's other parts of this data set that are compiled in different CSVs, so you're only seeing parts of this so far. And as you can see here, every time we execute something that involves Spark, there's going to be a job scheduled here, which you can get visualization on. So as we continue, we're going to be getting some more data here. This is going to show you some more features inside of this data set. We have domestic gas and heating gas. And then we're going to see another part of this data set here, which shows another part of the data, which is the name, the plug load consumption, AC consumption, domestic gas, and heating gas. These attributes are actually the important part of this data set. You're going to see how this data is actually coming together from about 4 of these attributes here. I'm gonna go to this. So just an FYI before I continue to the next part. With these notebooks, you're able to install Python packages via pip, or if you had an external, cheese shop for Python, you can just do a pip install with the URL flag to install the package. You can also do stuff with Scala the same way, install packages this way. And if you had your own private repo with the proper security and connectivity, you'd be able to install those packages via your notebook if necessary. So this is the second part. Anyone? Okay. So this is the second section, model energy usage in kilowatts an hour of buildings. These are the actual first rows that we're going to inspect for this watt hour data. As I stated before, the electricity usage, year of construction, number of stories, total square feet, and the actual plugged equipment. We're going to do data prep on it and then proceed. So, defining functions to clean and prepare the data. So as we proceed, we're going to actually apply that data preparation functionality to the data frame itself, fill in the missing values with an average from a feature matrix and scale the columns. So pretty straightforward. We're going to do some correlations here of the data. You can see that a lot of them are actually leaning to the left. It's pretty inefficient. Let's work our way down. Can you guys see this all right, by the way?
Yep.
See, from my angle, it looks really bad. So,
Yeah.
Okay. This makes it more difficult. Anyway, so here's the linear regression model that we're actually going to create here with the 4 attributes that I mentioned. Age of the building, square feet, number of stories, total plugged equipment. So as you can see here, it's kind of important to know that we're getting these attributes here and these coefficients in this segment. Now, I actually had a good discussion with a couple of the folks at datascience.com about model accuracy here. This is about 85, yeah, about 85%. So as far as the accuracy of the model goes, it's close. Let's just say that. So here's a little visualization of actual model accuracy itself. And as you can see with this 45-degree angle, you can see some of that cluster here show efficiency. Protect buildings that consume energy inefficiently. So here's a good thing to note. This quantile at 0.95 is showing the top 3 that are actually consuming the most inefficiently inside of the entire data set. So these 3 sources here are actually the highest spend for our data. And when we get to the actual the Shiny app, you'll actually be able to see that. Any dimensions are used to measure energy efficiency. So here's a couple of, 4 other attributes, 2 of which were earlier, 1 of which is new. And as you can tell, we work our way down, you're going to actually see a cluster of these 4 dimensions and these labels color observations. So there's some notes here that actually talk about that. Does anyone have any questions regarding this data set, how we pulled a lot of this together, more or less where this data is coming from? Yes?
Is this data set only available for us?
Yes, it is. Yeah. So you could actually pull this off of GitHub, spin up data science experience, go from the URL itself, it'll load it into data science experience for you. You start working from there. So this is public domain. So here's the confusion matrix. Oh, actually, let's get back here. So here's that actual classification model to identify the inefficient buildings. So here's that model accuracy here. It was about 86. I said 85. And the confusion matrices allow us to analyze the results of a classifier. So as you can see here, that first row of that confusion matrix, we actually have a very, it's pretty good in terms of the prediction of those efficient buildings. But that second row definitely does tell us it's not very accurate. So only 8 out of those 22 are inefficient. And finally, once we've verified that and have affirmation, some sort of confirmation that 8 of those 22 are inefficient, we're going to export that data to RStudio. And by doing this, we're actually going to load the data back into the object store after we have modified it. So we're going to actually do that here. And as you can see, we have the credentials, the container, the export data, and we're going to save that file name out. So obviously, it's not going to be listed here. It's going straight to the object store. So the source of the object store. It won't actually be loaded and visible from the files section. That's only specific to the project. So the data is now loaded. We want to go to RStudio. This is kind of the sausage making portion of how we got our data in place for RStudio to get visualization on the Shiny app. This is kind of the laborious portion. So glad I had the opportunity to kind of show you that. But how many of you have used R? Okay. And how many of you have had R crash on your laptop repeatedly? Okay.
Depends on the do.
A lot of times, right? So the good news is that if it's going to crash, it's not going to crash on your laptop anymore. It'll just crash and all on Bluemix. Yeah, on Bluemix, IBM's system. But yeah, so you can actually end up running it again. It'll just start the Spark kernel up again, and you'll be off to the races. So here, go ahead and. So it's similar to any other RStudio setup. You have full access to this. You have a console. You have the R Markdown language. And once it's launched, spawn a new browser.
So is this a fully fledged RStudio version?
Yes, it is.
So it's,
Yeah, straight out of the box. It's pretty sweet because of licensing costs and all the other things you have to do separately of your development environment or for your team. It's basically rolled into one package, which is kind of the powerful aspect of this, is that you don't have to go to multiple sources to do what you need to do. You just have one collaborative effort that's giving you that end-to-end piece so that you can move your data from here to a predictive analytics platform like Watson or whatever it is you may want, and visualize your data, verify everything's looking okay, or go back, retrain your model, and put that data back upstream to test some more. So this is a great end-to-end tool for function. So this is what our Shiny app looks like here. Let's go ahead and just select these. So as I was discussing earlier, we have that annual energy bill, the average energy compared to benchmark, and then the mean values versus or against the selected properties in question or property in question. So we have heat gas, home gas, which is domestic, AC, and plug, PL, EI. So as I discussed before, this is one of the top. This is actually one of the top ones. I got kind of lucky, right? But yeah, nine devices or things plugged into the building. It's doing pretty good on the home gas side. Heat gas, it's almost there in AC. So it's not bad, but it could be better. Let me just pick another one. You can see this was 150%, 115% the average energy compared to benchmark. And it's energy bill. So here's the cluster analysis in question that we were looking at earlier. Need the property name, price. Zoom in. So the cool thing about Shiny App too is you can do this in near real time also. So if you wanted to stream data through this app, you can definitely do that. If you had data collection from a data source, like a database or an S3 bucket, and you wanted to just have this keep running and listening for that data, you could pull that data, and then this would continue to populate with metrics. Very cool. And here's the predictive models. So this is Shiny App. We have a cool little slider here, which you can actually change number of outlets and all that other good stuff. Get a decent metric on the cost. But, hey, look at that. There's that one. So then what it all comes down to is after all the data has been modified, it's one single table. It's kind of a wide index. And now you have yourself an entire visualization dashboard that you can use at any time to get metrics. And you could update this at any time too. So like I said, if you wanted to have it scheduled, if you wanted to do something like, stream it, you could do it with Shiny Apps in our, yeah.
Question is basically you computed or maybe even pre-computed all the necessary elements you need for visualization in the notebook.
That's correct, all your rendering.
And basically no computing is done in Shiny. It's just pure a UI.
Yeah, it's all rendering. Yeah. So then you've basically taken the workload out of the UI, which has been an ongoing issue for most telemetry and visualization tools when you're monitoring, is that your biggest problem is you can get data in really fast, but you can never render at the same rate of speed. And that's usually an issue for a lot of monitoring systems in general. So with something like this is a great tool because you could do that with your notebook. So are there any questions regarding the RStudio portion? And yeah.
RStudio, I believe this is running again, connecting to our server, spinning up on some instance.
That's correct.
So our charge $10,000 for a single seat license.
Yeah, you don't have that.
Then our Shiny charge another license fee. So this is all
bundled. Yeah, and our pricing is, talking about pricing as opposed to the technology. We can talk about it later.
No, I'm not here about dollar sign. I'm not.
Yeah, dollar sign wise though, like 10 seats for all of this built in at $9,400 a month.
Yeah, as I said, I'm not a money man. I don't care about the
Yeah.
price. I'm just caring about
Cost
you're
benefit.
paying for one product.
Yeah,
So,
end to end. And the cost benefit's a lot higher because you're not doing a bunch of maintenance and other things too, overhead, patch management, et cetera, on other systems. So this is definitely beneficial in that sense. But technology-wise, we do have other pieces of data science experience here that we're bringing into the mix. Machine learning kind of as a service, which hasn't been released yet, and a couple other tools that we've talked about and people have heard about, but those are on the roadmap. So in terms of the scheduling aspect, it looks like a cron job. So if we went to a project, just case in point, with this example here, and we wanted to do something like schedule it, similar to a cron. kind of cool. If you had data landing inside of a data lake, like a Hadoop cluster database, and you wanted to do analysis on it at a certain time, there you go. That's one aspect of it I like a lot because I don't like to be on my desk. So, all the time. I live on my desk. Yep. So, any questions? Any other questions? Yeah.
Just to clarify, you're scheduling the job for the notebook.
That's correct.
Second,
Yeah.
okay. Second of all, just because I'm a more visual person and don't want to be saying, because having our server out there and the issue doing the compute, it's not easy to use your own idea. Do you have an architecture diagram on how this, because you're doing the compute as far, and I guess the results are being passed to, are landing back into your data store and then on your servers. I'm just trying to visualize in my mind how the flow works with Visual Studio.
Yeah, I mean, I don't have anything that I can just like quickly pull up right now. I do have some reference architecture that I can show you that's on internal use only. So I can give you a workflow of visualization. Yeah, definitely. I'd love to.
Okay.
Yeah, that's fine. Because functionally speaking, I mean, it's like if you have data coming in, you know, you're gonna have to put it somewhere, right? So whether it's a caching system or, you know, Kafka, for example, if it's high throughput, high volume, that's your boilerplate. You're gonna have to put that to a processing layer, consume that data, and then put it to a data source.
Right.
Once you put that to a data source, you know, it's landed. Now you have to access that data. How are you gonna do it? You're gonna use, you know, other tools, or you're gonna use something like data science experience to train the models that you're developing for production, maybe for some other part of the infrastructure. And then you're gonna test those samples, that data. And then what you're gonna do is you're gonna, you know, run that notebook and then go into, say, RStudio and get those visualizations from that dashboard. Why? Because maybe that's what you want to do, because you're doing statistical analysis and you're comfortable with R and you're a stats person. It's gonna be a lot easier than just writing straight Python or, you know, going using NumPy for everything. So it's generally the case. Yes, sir.
So in first part, when I'm using Spark and say my data sets are very, very large, don't have flexibility to specify the size of Spark cluster and backend insert.
Yes, sir. Yeah. So you would do that from there's a control here for that. You also have a way to provision more Spark executors when you have licensing for this in particular. I'm a single user, so I don't have a ton of executors to show as an example. But in the event that I did, let's go ahead and go to settings. And then you would have your storage, which is basically your object stored. You'd have your executor, which would basically be a part of the associated services. And you'd use Bluemix, which is a part of IBM's product platform, to create more executors.
So if I create a cluster with Bluemix, then I can link that here.
That's correct. So it's all single sign-on, and you have orgs. So if you had an org, you had 10 users in your org that are going to use this, you can allocate those resources to appropriately to each user from data science experience per project, or you do it from Bluemix and then just create 1, 2, 3, 4 executors, and then just label them. It's all according to how you want to use it.
At present, I use Bluemix for this stuff.
Oh, you do?
Yeah.
Oh, okay, cool. Okay, so you know kind of how it works to get the executor, and yeah, so it's pretty much one linear shot. You just have to go into datascience.ibm.com, log in with your credentials, and you'll be off to the races. Yeah. So, what was your question? I hope that answered it. Are you good?
I'm formulating a question. Basically, I was trying to figure out, I mean, you showed us a notebook where you use PySpark, and then you wrote the data, and then you use Shiny to access that data to display it.
Inside of the RStudio.
And I was trying to figure out what is the value add here? Like, I've done those things independently.
Right. So the value add would be you're using something that's all-encompassing, not on your system locally. You're not causing any sort of data issues either by connecting from your laptop to, say, a production data source, or even a staging data source, or maybe some other data source, for example, you can connect directly through this cloud collaborative environment, get your data, share it with your team, do everything you're doing, create versions of this, then push it back up into GitHub. So now you have this tool that's not only collaborative, but it's part of your software development lifecycle now. And on top of it all, you're not using your local laptop's resources. With, say, data samples that are somewhat stale, you could be pulling it from a data source that's read-only and do the data manipulation you need. I mean, some people can argue that, hey, I can do that even from my laptop. I can go to a server, log in, start doing stuff, but there's access controls and issues with that in some organizations. So this would be a very easy tool to use to bypass those controls properly.
I also see the opportunity to get Bluemix involved too, because there's, because then you have some
Interoperability.
ML packages in there that you just.
Yes, you could do that. So you can use NLP, text, speech to text, other things like that, and then integrate those tools into.
So that would be possible.
Yeah, you could do that.
Okay.
Yeah. I mean, it wouldn't be something you just like drop in and go. You have to design it. Yeah. So you can get the data that you got from the NLP libraries or the NLP tools that we have in Bluemix. Take that data, save it, put it into the object store, -db, or wherever you want to put it. Compose is Postgres, right? And then just wherever it needs to go. And then just access the data and train your model.
How do you compare, this data science cloud platform with Databricks cloud?
Comparatively, I think the interface is a little more intuitive with data science experience with this new iteration of data science experience than the old Databricks cloud. I also haven't tried anything really heavy duty with Databricks cloud, so I don't know how it would handle compared to what I've seen with data science experience. Like a 600 meg file, for example. Say I load a 600 meg file into DSX with just the freemium version, you can do it. That's a lot of data when you're talking about translation and things like that inside of Spark. You're duplicating the file basically. Say you have 1.2 gigs of file, and then you're doing data processing on that file, and you're doing more data massage and then deleting the old file and doing more data manipulation and things like that, and it still can run with no problem. So I haven't seen it like topple over in that respect, and that's in free version.
The free version.
That's correct.
It says 5 gigs, and is that the limit?
Yeah, for the free version, yes, and one logical
And
store. Yes.
Do you have any limit on the notebooks?
I haven't exceeded any notebook limits yet, which is kind of weird. Maybe I haven't tried it hard. I haven't tried hard enough.
No, I don't think they charge.
Yeah, it's just,
You can run only one.
well, if you schedule it right though, you could like schedule it back to back to back though.
Yeah, but it's
Cool.
still
It's one at a time, it's sequential.
because that's and you pay if you want to get the data out.
Wait, repeat that part? I'm
Do you
sorry.
want once you get the data, the visualization, you may want to get it out.
So you can do that.
Do you charge for it?
As far as I know, no. You don't have to pay for data egress, no. Because it's just you're paying for the data source when you're paying for the licensing. So everything you're getting with this inside of this package, what I'm showing you, it comes with it. That includes like, how many terabytes? I don't remember how many terabytes. I think I don't remember the exact size. Is it 10 terabytes? I thought it was, it's a lot of data. For the enterprise, right? Yeah, maybe it is, yeah, like 10 terabytes. You got that much data, good for you. So
What kind of security features you offer for data side?
So inside of data science experience?
Yeah.
So we have secure gateway, which is basically like a tunnel, similar to direct connect in AWS, between like site to site type of connection.
Is your data encrypted, or can you encrypt the data once you?
You don't need to.
You don't need to encrypt the data.
No.
Yeah, the VPN tunnel's encrypted, so
No, I mean,
what do you
by
mean?
default, enterprise companies don't like the fact that the data is on the cloud. So some of them want to say they want data encrypted because the feeling is that you guys can still touch the data.
Well, technically, if you have an agreement with us, that's a good question. There's some governance there.
They can't do that. If
They
encrypt
can't touch it. Yeah,
No, if you guys encrypt the data, then
yeah.
But then who manages the keys if you encrypt it?
You would.
So we are
so
the.
You'd have the keys.
Oh, we would have.
Yeah, yeah. Oh, definitely. You'd also have access to update those keys.
Okay.
You know, do what you need to do in terms of user management too. So you have ACLs. I'm just trying to understand the concern. So you're talking about. So what you're talking about is landing data. Is the data encrypted at rest, or is it data encrypted over the wires? You're concerned because
Both.
both. But still,
it's still-
they have to be able to
It
decrypt it
is.
to do the analysis.
That's
So
correct.
They will have the keys.
Yep. Yeah. So I mean, ultimately, it's going to be encrypted at rest.
If you have that scare that, okay, I don't want IBM to see my data, then you can't use that.
Yeah. Yeah. You wouldn't be able to use any cloud data science platform. You can use
No, you
data
can-
science.
You can use AWS. You can have we manage some. They allow it.
Yeah, but what I mean by that is you manage it.
Yeah, we manage the keys.
Yeah.
So you're
So-
using the infrastructure.
Yeah, you're using infrastructure as a service as opposed to a platform as a service.
Okay.
You
So
can
this is-
do that.
Yeah, but ultimately, if you're writing to S3, for example, you can encrypt that as well.
Yeah.
So it's
You have to decrypt the data for the analysis.
right. So if you're going to do that, you'd have to have the keys.
So if
So
you have
you're kind of darned if you do, darned if you don't. Seriously. Yeah. So yeah, but that's not an issue in terms of controls because if you're the owner and you're keeping track of the keys and do key rotation, I mean we're going down a rabbit hole now.
some people because did you guys get certified? Like HIPAA?
We have compliance certifications. Yes. Yeah, we have SOX, we have HIPAA, we have ISO 12701. CGIS, I think, I don't want to say yes, but for some weird reason, I think we do. I'd have to look that up. If you, yeah,
Trouble to go.
yeah, I would have to check. I don't want to say we do without verifying. So give me your info and I'll find out. Because I'm pretty sure I'm sure there's companies out there and people that are using data science experience that are, yeah, capable of doing CGIS work or GIS work. You know. Anything else? Any other questions?
How is it just to set up the VPN?
Yeah, you just put in the credentials and you're good to go. The IBM does it for you. And yeah, with your security team. So
you give the software or
Well, you would just have, yeah.
VPN client?
Yeah, you get the
Something
VPN
else,
client.
something on the side.
Yeah, you get the software from us.
Okay. Do you have an appliance if it's too much space?
That I don't know. I know that we have a group working with, I think it's Spera.
You get that,
Yeah. They're doing VPN stuff.
So you don't have to do it.
No.
Do you have any idea how much the licenses cost?
For DSX, the whole package here, I think it's 9,400 or 9,600 a year. Oh no, a month. It's monthly with 10 seats.
10 seats.
Yeah, so it's quite a few people. Most data science teams are, and we do have options for like 5 now.
And then how much in data can you upload in the 9400?
I think 10 terabytes.
Oh, okay, that's it.
Yeah, it's quite a bit. I think that's what Christine had mentioned. So I'm going by her. Yeah. So and you get I think 32 logical cores and
So we would have to clean up the
quite a bit
data.
of RAM.
You
would have to clean up and push it.
Yeah.
We would have to clean up, push it up, so it can be.
Correct. Yeah. So if you have like an S3 bucket or something like that you want to store data in, or on-prem, yeah, you could do that.
You always keep saying S3. You guys have something that's like S3.
Yeah,
Closer to-
Swift Object Store.
Which is closer to. all of it.
Yes, Swift Object Store is what we provide.
Mhm.
It's very fast.
To move the data from the.
Yeah, so data movement's gonna be a lot faster with Swift Object Store than
Or picking it up and getting.
the correct. Yes.
Linux is actually integrated or is can be run on any cloud?
So we have an on-prem solution for Bluemix, which is basically, we install it for you, manage the services for you, or you guys can do some degree of that. And then we also have our managed Bluemix service, which is actually hosted through Software. So a lot of the compliance that Software has, we have in that respect, because they're doing the managed service for us.
Question is, if I be a partner with Bluemix, can I integrate this solution as well? Because you show it's like Spark can be as a service.
Yeah, so if I have another notebook in here, we don't have to go down the rabbit hole, but I'm connecting to a -DB instance that I have, and I'm collecting Twitter data and then also geolocation data from another source. And I'm taking that data and doing some manipulation to it. And one is coming from a streaming API into Dash. The other one is actually loaded data that I loaded pretty much by hand. And, operations-wise, like everything's built in and accessible with the proper credentials. That's all you need. Once you're connected through Bluemix to DSX, you don't have to do anything, otherwise it's all in the same part of the infrastructure, same company, same source.
You guys have like a startup?
Startup guide?
Yeah, like
Yeah.
how you go where you sign up.
Oh yeah,
You post it.
yes, of course. I can actually do kind of if you mind just a flat file. I don't usually do
No,
like.
not the flat file, just a link to the.
Oh, okay.
The file. I was expecting it. Thank you.
Yeah, I can do that. What I'll do is I'll send.
Like how do you sign up for like nothing to get the people to the viewer to dip their hands and try it out, see how it works, and then when they like it, they sign up.
So I
Just for the POC.
Yeah. So I do PO, they call them POTs, proof of technologies for Spark, and we do a lot with the integration of Bluemix to DSX and do various things with Spark, machine learning, Spark SQL, etc. So we generally go through those. I can take some of my content and put it up to the meetup site that will give you that step-by-step of what you have to do.
To make the first.
Yes, you'll get a 30-day free trial. You go ahead and use it, and I'll put my email in there, and if you have any questions, feel free to ask.
Yeah, sorry.
No,
So
okay.
just going back to kind of to visualize how the data flow and how this all works. And because
Sure.
you brought up S3, so
Yeah.
let's just say I have terabytes of data in S3, and then you guys can connect to that. Can you help me understand? Do you guys end up connecting to S3 and moving the data so you can do compute, or how would you?
We're collecting the data in memory and then processing that data.
So it's, it is.
Yeah,
It is okay.
over the wire, but it's secure. But it's 4/4. You're going through a SSL.
So there's
session,
some
right?
latency there.
Yeah, you're gonna have HTTPS, right? So
Okay.
it'll be over the wire, public network, using HTTPS and your credentials.
I'm
So,
thinking for big data, I'm thinking large amounts of data sets. If we need to score huge amounts of data sets.
well, you shouldn't be doing huge scores of data sets inside of like a notebook in the first place.
Well,
usually.
but you said you could production it through a cron job, right? If I want to.
Yeah, to train a subset of your data.
Then if
to
I
model
want
it.
to operationalize that.
Yeah, you would then commit that code to say, okay, so when you're done with it, if I say your model looks good, everything is okay, and you're clear for takeoff to get code review. At that point, once you're done developing it in that sense, maybe you have a dev environment in your infrastructure. You would then push that code or commit and push to your dev branch or your branch in GitHub. Then from there, you would merge it to dev, have the build kick off with that code in there, deploy it to your dev environment, test it again. Okay, cool, it looks good. Then what you do is you say, okay, now I'm gonna, push it to staging, tag it, and then take that tagged version that you pushed to staging up to prod,
No, I understand.
Yeah,
that.
I mean, it's-
I know
yeah, yeah.
That's the problem, but I'm just trying to see if I'm gonna stay on, say, S3 or on Azure Blob, how do I don't wanna have to.
Actually, may I get my 2 cents?
Yes, of course.
Actually, if you on S2, S3, it's a storage. So this one is a blue mix. Just get storage, transfer it there.
So the
Give me a
transfer.
lot. Well,
It would-
logically, yes. Otherwise, you're incurring a lot of traffic from Amazon.
Fees,
And Amazon,
yeah.
it's not cheap.
Outbound fees for Amazon is really expensive. Oh, yeah, in public wise, yeah, you're paying a lot.
Yeah, so
Yeah.
it's much better just, like drive than.
Sure. No, I understand.
It might even be cheaper to use like Glacier or the cold backups that, AWS has and then move it that way.
Okay, it's just another step that I'm just trying to understand.
Yeah.
You would have to do, because I'm trying to separate the storage from compute here. That's what I'm.
Sure, oh, yeah, definitely.
In this case, for IBM, for your product, it still has to be for efficiency cost, you're still gonna have to put together, right? And the latency issues.
I mean, latency wise, you're not gonna see that much, but I'll be honest with you, latency isn't the problem with when you're modeling data and you're working with the data sets that you're gonna be working with. If you're working with like terabytes, you might see some latency. But if you're talking like a gig,
Yeah, that's not what
that's nominal. Now, I would be more concerned with something like cost in the benefit of why you move it from S3 to an object store. Maybe if you're connected with a secure gateway, you're already paying a fee to be connected with a VPN that's pretty much accelerated in some respects. So you can still connect to your on-site. And if you have direct connect, this is the other thing too, is if you're in cloud, and you have a hybrid infrastructure that's also bare metal, you're already probably direct connecting to AWS, right? So why don't you store your data, if you're gonna land your data for your data scientists to do your modeling, land it in-house, do the modeling from there, and use secure gateway to do the data movement, because the cost is gonna be cheaper in general, if you're doing it that way, than going from out public to public, like a public.
Depends if business have in-house.
Exactly.
Most company try to
Yeah.
offload it, and it's like when they see deal, they say, well, we should.
100%, and I've seen that as well. So your mileage varies based off of your needs, and also making that educated guess on what you want to do first and foremost with your management. So, any other questions? We're
So
good.
just one more question.
Yeah.
Anyone? Just one more question.
The option is they can swap and swap users.
Yeah. You use Bluemix and Object Store.
Yeah.
Okay. Cool. Well, thank you all for your time. I hope this was somewhat educational and gave you guys some insight on how data science experience works with block power and some visualization tools. So thank you. Everyone's starting them, so
Feel free to stick around. There's food out there. And help us out.
I just want to.
Okay, thanks.